Microsoft and UC Berkeley have developed a beast called Gorilla. It's faster, smarter, and transforms your projects with seamless AI collaboration. Ready to know how it works and how to access it? Keep on watching. Gorilla is a computer program that can generate natural language the same way humans communicate. It can understand natural language and use it to communicate with other computer programs. These other programs are called APIs, which stands for Application Programming Interfaces. APIs are like instructions or commands that tell a computer how to utilize a tool or a service. For instance, Google Translate has an API that allows other programs to use its translation service. Banking apps have APIs that enable you to shop online. Foodpanda has an API that assists you in ordering food. Kind of like how different puzzle pieces fit together to create something cool. Gorilla can discover and utilize APIs from various platforms, including Hugging Face and TorchHub to TensorHub and Google Translate. It can use these APIs to assist you with your tasks. For instance, if you want to translate a sentence from English to Chinese, Gorilla can locate the Google Translate API and assist you in translating. If you want to create a summary of an article, it can find the Hugging Face API and request it to summarize. If you're interested in generating an image of a cat, it can identify the TensorHub API and instruct it to create one. It can even perform complex tasks like booking affordable flights and using the Foodpanda API to order food. What would be your first use of Gorilla? Let us know in the comments below. How Gorilla works, we need to understand some technical terms. Don't worry if they sound complicated at first. We will explain them in simple language. It uses a large neural network, which is a collection of mathematical functions that can learn from data. The neural network has many layers, each of which performs a different operation on the text data. The layers are connected by weights, which are numbers that determine how much each layer influences the next one. How does Gorilla distinguish itself from others? Numerous computer programs available in the market today can generate natural language. Some of the most popular ones include GPT-4 by OpenAI, Claude by Anthropic, and Bard by Google Research. These programs are often referred to as large language models, LLMs, as they utilize vast amounts of text data to learn the intricacies of natural language generation. While these LLMs boast remarkable capabilities and applications, they also present certain limitations and challenges. One significant challenge is their occasional tendency to make mistakes or inaccurate guesses when interfacing with APIs or external tools. Instances of using the incorrect API, input, or output may occur. Additionally, there is a possibility of these models inventing concepts that are untrue or not feasible, a phenomenon referred to as hallucination. For example, if you ask them to provide details about the best games of LeBron James, they may include fabricated games with incorrect information. Some models, like GPT-3, even utilize outdated data from 2019 and cannot offer details about events that occurred after 2021. These errors can render their text unreliable, misleading, and nonsensical. Another challenge posed by these LLMs is their tendency to occasionally generate inappropriate content. Moreover, they might produce texts that are plagiarized, contain confidential information, or are illegal. This can result in harm to users' or recipients' reputation, privacy, or safety. These challenges arise due to the limitations in data and methodologies employed by these LLMs to learn and generate natural language. They are trained using deep learning, a technique that employs intricate mathematical functions to learn from data. However, deep learning is not always transparent, explainable, or controllable. Understanding the decision-making process and factors influencing their outputs can be difficult. These limitations and challenges undermine the trustworthiness and utility of these LLMs for both users and society at large. This is where Gorilla steps in. It excels at generating natural language compared to these LLMs by utilizing a distinct approach. This is because it constructs natural language using APIs as foundational components. Through the use of APIs, Gorilla sidesteps the errors and issues that plague LLMs when interfacing with external tools. It leverages APIs that are verified, secure, and compliant with legal standards. It can use APIs better than other LLMs because it uses some unique features, like documentation. It is like a manual that explains how an API works and what it can do. It can read the documentation and update itself when there are changes or new versions of the APIs. This makes it more flexible and adaptable. It can also handle changes in the API, such as new features or bug fixes. Another unique feature of Gorilla is that it can use self-attention to learn from text data and APIs. Self-attention is a technique that helps Gorilla find the most relevant parts of a text for a given task. For example, if Gorilla wants to write a summary of an article, it will use self-attention to focus on the main points and ignore the details. Self-attention also helps it understand the context and meaning of words and sentences. It also helps Gorilla communicate with other computer programs and use them to perform tasks. For example, if you want to use an API to create an image of a cat, other computer programs might generate an image that is blurry, distorted, or unrealistic. Gorilla can generate an image that is clear, realistic, and consistent with the text description by using self-attention to understand what a cat looks like and how to use the API. Other LLMs have security problems, and many businesses don't use them because of this problem. Gorilla uses encryption and authentication to protect the data and the communication between the software and the APIs. It also uses verification and validation to ensure the APIs and outputs' quality and accuracy. Verification is a technique that checks if the APIs and the outputs match the specifications and requirements. These techniques prevent errors, bugs, or failures of the APIs and the outputs.